Hello students, so let's continue our NCERT chapter 7, that is alcohol, phenols and ethers. This is the disclaimer. Now, what is the objective of today's lecture? So, after attending this lecture, you will be able to understand the topics that we are going to cover today. So, today we'll discuss about some commercially important alcohols. So, we will see that how these alcohols are important and what all are the properties of these alcohols. So mainly we'll be discussing about methanol and your ethanol. So for your reference, I have also mapped the NCERT sections that I'm going to cover today. So today we'll be covering section 7.5, that is some commercially important alcohols. And for your better understanding of the topic, we will also solve some in-text question. So questions 7.6, 7.7, 7.8 and 7.9. So we are going to solve these 4 in-text questions. So let's begin with some commercially important alcohols. So first we are going to discuss about methanol, which is one of the simplest alcohols. So if you remember, in case of alcohols, I told you that in case of alkane, the E is replaced by OL. That is how you write the nomenclature of alcohol. And since here there is only one carbon atom, so the root word is meth. And all denote here that this is an alcohol. Okay, so this is methanol. Now methanol is one of the simplest alcohol which has the chemical formula CH3OH. Now if we talk about historical production, that how in earlier times we were not having such machineries and factories. So how in earlier time your methanol was produced? So it was originally it was produced by the destructive distillation of wood. That means your wood, it was heated strongly in the absence of air, and this was called as destructive distillation. So it was also known as wood spirit over that time in historical times. Now if I talk about modern production method, that right now what modern production methods that we are using to produce the methanol. So it is produced by the catalytic hydrogenation of monoxide. That means the gases like monoxide and H2 gases, these gases are used in modern times for the production of the methanol. So during this catalytic hydrogenation, to produce your methanol, this requires high pressure and temperature. Now the catalyst which we use for this is zinc oxide and chromium oxide, that is Cr2O3. So both of them, they are used as the catalyst for your production of the methanol. Now if you look at the reaction, you will see that carbon monoxide plus H2, that is catalytic hydrogenation. So catalytic hydrogenation word suggests that H2 will be used, and catalytic means it will be done in the presence of a catalyst. So here your carbon monoxide plus H2 in the presence of a catalyst, which is ZnO and Cr2O3. It produces methanol. And look at the temperature condition. It is 573 to 673 Kelvin. That is at a very high temperature. And pressure is also 200 to 300 atm. So the conditions are harsh over here. So this is how you produce the modern production of methanol is done using carbon monoxide. Now if we talk about physical properties, that how does this methanol looks like, then this methanol is a colorless liquid. That is, it do not has any color. And the boiling point of the methanol is 337 Kelvin. Okay, that if you need to boil the methanol, you have to bring it to its boiling point. So the boiling point of methanol is 337 Kelvin. Now we will see about the toxicity of methanol. See, methanol is very toxic. Even the minute quantity of methanol is also very toxic. So it is highly poisonous substance. Even if you just use little bit of methanol, it is very poisonous. And it has side effects. Being highly poisonous, the small quantities can cause blindness. So even if you are using the small quantity, it can cause the blindness. And the large quantities can be fatal. Okay, it can even cause the death if you have consumed in the large quantity. So that is why this methanol, it is unfit for drinking. That means it is not used as a drinking alcohol. The alcohols which are available in the market for drinking, methanol is not that alcohol. Okay, because methanol is very poisonous. Even the minute quantities can cause the blindness and it can be fatal for you. Now if we talk about the uses of methanol, that at what industry level or where this methanol is being used, then your methanol, it is used as a solvent for paint, varnishes and celluloids. So this works as a solvent for paints, varnishes and celluloid. And it is also used for the preparation of formaldehyde, which is also called as formalin. So this is about the methanol, that how in historical times your methanol was produced and it was called as wood spirit, and how in today's time we produce the methanol using carbon monoxide. And then we saw that the methanol is very toxic, and then we saw about the uses of methanol. Now we will talk about ethanol. Ethanol, there are two carbon atoms. So the root word is ethane, and E is replaced by OL if we are talking about alcohols. So it is ethanol. So the molecular formula is C2H5. So the compound with the chemical formula CH3CH2OH is your ethanol. Now it is the main constituent of alcoholic beverages. That means the alcohol which is available in the market for drinking, that is your ethanol. Okay, so this is the alcoholic beverages which is available in the market. Now if we talk about industrial production of ethanol, then ethanol is produced by the fermentation process. Okay, so it is made from the sugar using yeast. So sugars are converted to ethanol by yeast, and this process is called as fermentation process. So what happens in this process? First, your sugar, that is sucrose. So sucrose is C12H22O11. So sucrose is reacted in the presence of an enzyme which is called as invertase, and it produces your glucose and fructose. Then further what happens? Then your glucose or fructose, it is reacted in the presence of another enzyme that is called as zymase, and then it forms the alcohol, which is ethanol over here, and your CO2 gas is being released in this process. So first your sucrose, in the presence of the enzyme invertase, it is converted to glucose and fructose, and then your glucose or fructose is reacted with another enzyme that is called zymase. It forms your ethanol, and this ethanol, along with this ethanol, your carbon dioxide gas is also released. Now what happens is that this ethanol, if it is exposed to air, then this ethanol can oxidize. So the presence of air, it can oxidize this ethanol to your ethanoic acid. So look at this reaction. This is ethanol, that is CH3CH2OH, and in presence of this air you will see that ethanol, it is oxidized to ethanoic acid. Ethanoic, it is a carboxylic acid. See the group, it is C double bond OH. So it is ethanoic acid. So what will happen if your ethanol is exposed to air? It will get degrade, it will get oxidized to ethanoic acid. Now, if we talk about the industrial production of ethanol, that how at industry level this ethanol is produced, then it is done by the hydration of ethene. Okay, let us see how it is done. Look at this reaction. So hydration over here means hydration words itself represent that water must be used here. So ethene, when it is reacted with water in the presence of H3PO4 as a catalyst, look at the temperature, it is 573 Kelvin, and under high pressure, so it forms a alcohol, that is ethanol. So if you look at ethene, in ethene you have double bond. Okay, that means in double bond there are pi electrons. So these electrons are easily bounded. So that means this can be donated, these pi electrons. So look over here, this is H2O, that is H plus and OH minus. So first, if we will protonate this H2O with H plus, it will form H3O plus. Okay, and when this H3O plus is reacted with your ethene, so what happens, this double bond from here, it reacts with this one of the hydrogen, it attacks this hydrogen with its electrons, and then you will see that a carbocation is formed. At this carbon you will see a positive charge is there, and to this carbon one hydrogen will attach. Okay, so at this carbon there will be a carbocation. Now what we will do, now this carbon is electron deficient carbon, so a nucleophilic attack will happen. That means your OH, this water molecule has oxygen which has electron density. Okay, so there are lone pairs present on this oxygen. So here your carbon is electron deficient because of the carbocation. So what will happen, this oxygen will donate its electron density to this carbon. Okay, and your OH2 group will attach to this carbon. Okay, then what will happen at last step, there will be deprotonation of deprotonation, and you will get your ethanol, that is CH3CH2OH. Okay, so this is how from ethene you get your ethanol. First there is hydration of ethene, and then at this carbon there is a positive charge. Then what happens, the nucleophilic attacks happen, that this O has the electron density, so this oxygen attacks on this carbon and the water molecules get attached to this carbon, and then there is deprotonation of ethanol and you get CH3CH2OH. So this is how by the hydration of ethene you will form ethanol. Now if we talk about the properties of your ethanol, then it is a colorless liquid. Okay, that means this liquid do not has any color, so it is a colorless liquid. The boiling point is 351 Kelvin. That means if you have to boil ethanol, first you have to bring it towards its boiling point. That is 351 Kelvin. Okay. If I talk about the uses of ethanol, that where this ethanol is utilized, then the uses will be, it is used as a solvent in paint industry. So it used as a solvent in your paint industry. Next, it is the synthesis of the organic compound. If you have to synthesize the organic compound, then the ethanol is used for the synthesis of your organic compounds. Next, as alcoholic beverages. See, this ethanol being alcoholic beverages also has many side effects. Okay, it attacks on your central nervous system, or it affects your central nervous system, and it causes the unconsciousness. And even if you consume alcohol at a higher amount, then even it can be fatal for your life, because it can damage your livers and kidneys even. Okay, so that is why you should avoid drinking these alcoholic beverages. Now, denature of alcohol, denaturation is alcohol refers that making the ethyl alcohol, which is an ethanol, unfit for human consumption by adding toxic or bad tasting substances. Okay, so if this is ethanol, so this ethanol is made unfit for drinking, for this human consumption. So when you make this ethanol unfit, this process is known as denaturation of alcohol. It is made unfit for the human consumption. So how you make it unfit? You add some toxic or bad tasting substances. So as I told you that methanol is very toxic. So if you add methanol into this ethanol, then this ethanol will now not be an alcoholic beverage, because now it is unfit for human consumption. As I told you that methanol, even the minute quantity is very poisonous of methanol. Okay, so your ethanol can be made unfit for drinking by adding the methanol. By adding you can add any toxic or any bad tasting substance. And this particular process is known as denaturation of alcohol. So this is, we studied about two commercially important alcohols, that is your methanols and ethanol. Now if we talk about the preparation of alcohol from grapes, then we will see that grapes, they are very rich in sugar. Okay, so grape is very rich in sugar and it has a natural yeast on its skin. So they are the primary source of your both sugars as well as yeast. Now what happens is during ripening, they are preferred for making alcohol during the fermentation. So if I talk about grapes, then these preparation of the alcohol from grapes, then what happened, they are preferred, then these grapes, they are preferred for making the alcohol by the fermentation process. So during ripening, what happens, that the sugar content in grape increases. So grapes are crushed to release the juices. Okay, and these juices contain your sugars and enzymes from both fruit as well as your yeast. So yeast, it grows on the grape skin, and in the fermentation process, what happens in the fermentation process, that it begins when grapes are crushed. So grapes, they are being crushed to release the juice, and the sugar and enzymes, these both are mixed together. Now all this fermentation process, it occurs in anaerobic condition, that means in absence of air. Okay, why it occurs in absence of air? Because if air can oxidize your ethanol to your ethanoic acid, so to avoid that oxidation, this process occurs in anaerobic conditions. And when this process happens, then the carbon dioxide is released as a byproduct. So it produces CO2 as a byproduct. Now look, air exposure effects, this is what I told you, that when your ethanol is converted, your ethanol converts to ethanoic acid if it is exposed to air. That is why when you see that the wines, it comes in a sealed, it is sealed to prevent this from spoiling. So wine bottles are always sealed to prevent its oxidizing and to prevent the spoiling of that wine. So if ethanol will get converted to ethanoic acid, if your wine, it will get exposed to air, then it will ruin the taste of that alcoholic drink. Okay, the taste or smell, it get ruins. That is why it is taken care that the wine bottles are sealed. So this is how you use the preparation of alcohol from grapes. Okay, now let us solve some in-text questions. So this was some theoretical part about the methanol and ethanol, which we studied about its uses or how you are going to make it at industrial level. Now let us discuss some questions. So first question is that give the structures of the products you would expect when each of the following alcohol react with. So first is HCl and ZnCl2. Next is hydrogen bromide, and third one is SOCl2. So you have to write the products when alcohol will react with this A, B and C. Okay, so your reactant is first is butane 1-ol and second is 2-methyl butane 2-ol. So first you will do it with HCl, ZnCl2, then with HBr and then with SOCl2. So I'll give you 30 seconds to solve this question and then we will discuss the solution. Okay, let us see the solution now. So first is the reaction of butane 1-ol with HCl, ZnCl2. Now, if you remember that when we were studying about the alcohols, there I told you that this is Lucas reagent. HCl and ZnCl2 is a Lucas reagent. Okay, so that means you are reacting your butane 1-ol with Lucas reagent. Now, first you have to see that this butane 1-ol is a primary alcohol, secondary alcohol, or tertiary alcohol. Because I told you that Lucas reagent is used to differentiate between your primary, secondary, and tertiary alcohols, and it shows different reaction with different alcohols. Okay, so first this HCl and ZnCl2 is known as Lucas reagent. Now, if we talk about butane 1-ol, then this butane 1-ol is a primary alcohol. Okay, why primary? Because the carbon to which your hydroxyl group is attached is further connected by one carbon atom only. So that is why it is a primary alcohol. So when we were studying about Lucas reagent, there we discussed that this primary alcohols, it do not react, the primary alcohols, they do not react with Lucas reagent at room temperature. So at room temperature, they do not react. Now what happens? Your alcohols, they are soluble in your Lucas reagent, but their halides, they are not soluble in the Lucas reagent. Okay, that is why they produce the turbidity. Turbidity meaning like if you are taking a sugar, if you are taking a glass of water and you are adding a sugar, then sugar will completely dissolve into that water. Okay, so that will be a transparent case that you can see through that water. But when I talk about, if I ask you to take mud and put it in water and you mix it, then that solution becomes opaque. Opaque means that now you can't see through that solution. So that is, it produces turbidity, that when you mix a substance which is not soluble in your given solvent, then it produces turbidity. So this is with the case that are alcohols, they are soluble in Lucas reagent, but their alkyl or their halides, they are not soluble in Lucas reagent, so they produce turbidity. So when we talk about primary alcohols, they do not react with Lucas reagent at room temperature. Okay, so look at this reaction. This is butane 1-ol. I told you that this is a primary alcohol. See, because this carbon is further connected by one carbon atom only. So when you use this Lucas reagent, that is HCl and ZnCl2, you will see no reaction at room temperature. But if you take this reaction at higher temperature, then your primary alcohols, it will react with Lucas reagent. Okay, so what you will see white turbidity of alkyl halides. Okay, because I told you that alkyl halides of your alcohols, they are not soluble in Lucas reagent. So that is why you will see a white turbidity. A white turbidity will appear. So look at this reaction. This is butane 1-ol. Okay, and when you add the Lucas reagent, now look, the temperature is high over here. So you will get a alkyl halide. That alkyl halide is 1-chlorobutane. Okay, so see here, to this carbon your Cl group is attached. Okay, and I'll do the numbering from this side, 1, 2, 3, 4. So that is, it is 1-chlorobutane. So from your alcohol you got alkyl halide and water is being released. But this is only done at high temperature, because your primary alcohols do not react with Lucas reagent at your room temperature. Okay, it is important for you to know that how your Lucas reagent react with different kinds of alcohols, because most of the time this question is asked in your exams. Now if I talk about 2-methyl butane 2-ol, then you will see that this is a tertiary alcohol. Okay, so tertiary alcohols, they react immediately with your Lucas reagent. Okay, so now if you will see the reaction, so when you will react a tertiary alcohol, the white turbidity appears because of the formation of immiscible alkyl halides. Okay, but the tertiary alcohol, it will react immediately with your Lucas reagent. So if you see this carbon, then to this carbon other 3 carbon atoms are also attached. So this is a tertiary carbon. Okay, and to this carbon your OH group, that is hydroxyl group, is attached. So if I'll do the numbering of this, then this is the longest carbon chain, this one. So 1 2 3 4. So at second position your methyl group is attached and hydroxyl group is attached. So it is 2 methyl butane 2 all, and it is a tertiary carbon. So when you will see, when you react it with Lucas reagent, that is HCl and ZnCl2, then you will see it will produce a white turbidity, it will produce a alkyl halide. So this OH group will be replaced by your chloro group, that is Cl group, and water will be released. So it is 2 chloro 2 methyl butane, and it produces a white turbidity. So this is how Lucas reagent react with your tertiary alcohol. Okay, so if you take the Lucas reagent with the primary alcohol, then with primary alcohol it do not react at room temperature. Okay, if you want to react primary alcohols, then you have to increase the temperature. If I talk about secondary alcohols, then in secondary alcohols your Lucas reagent react with secondary alcohol, but this shows this reaction after some time. Okay, means they react after some time. But if I talk about tertiary alcohols, then these tertiary alcohols react immediately with your Lucas reagent. Okay, and you need to remember that your alcohols, they are soluble in Lucas reagent, but their halides, they are not soluble in Lucas reagent. That is why they produce turbidity. Okay, so this first part I hope is clear now, that how butane 1 all and 2 methyl butane 2 all reacts with Lucas reagent. Now we will see HBr, how hydrogen bromide reacts with butane 1 all. So when we will look at this reaction of butane 1 all with HBr, so what happens? The reaction of butane 1 all and HBr, it produces 1 bromobutane. That is, your bromine group get attached and your alcohol group is replaced by your bromine group. Okay, now this reaction follows a nucleophilic substitution pathway. That is, the nucleophile will attack. So what will happen? Your OH group, that is your hydroxyl group, this hydroxyl group is replaced by your bromine group. Now look at this reaction. This is butane 1 all. Okay, when it reacts with HBr, now look at the final product. In final product you will see that your carbon and oxygen bond is broken. Okay, so carbon oxygen bond is broken and carbon halide bond is formed. So what kind of cleavage is this? Which bond cleavage is taking place? Carbon oxygen bond cleavage is taking place. So if this happens, then how does your alcohol behaves? Your alcohol behave as an electrophile in this case when your carbon and oxygen bond is cleaved. Okay, so in this case, first we have to make this alcohol as an electrophile, because when we will make this alcohol as an electrophile, then only a nucleophile will attack this. So how we will make this alcohol as an electrophile? We will protonate this alcohol. When we will protonate this alcohol, this OH group here will become OH2. So there will be a positive sign on this oxygen, that it is OH2 plus. Okay, now this oxygen you will see over here gets a positive sign. Now what will happen over here? Your Br minus will come and attack at this carbon, So your Br minus will come and attack at this carbon and your OH2 will leave over here. So this is a nucleophilic attack. Okay, Br minus here is a nucleophile. It will come and attack at this carbon and your OH2 group will leave from here. So you will see water, it is minus H2O, water is leaving. So when this water leaves to this carbon, your bromine group gets attached. So this is from alcohol you produced 1 bromobutane. Okay, now if I ask you what pathway does this reaction follow, SN1 or SN2? Then this reaction follows SN2 pathway, because here primary alcohol is formed. Okay, and when I talk about primary alcohols, then as in this reaction you will see that no carbocation is being formed. So that is why your SN2 reaction is being preferred over here. Okay, now let us see the next one, that is 2-methyl butane 2 all. So now we will see the reaction with 2-methyl butane 2-ol with hydrogen bromide, then your 2-methylbutane 2-ol will react with your hydrogen bromide to produce 2-bromo 2-methylbutane. Again you will see that your OH group will leave and your bromo groups gets attached. Now this reaction will also follow your nucleophilic substitution pathway, that a nucleophile which has the electron density to donate will attack your carbon. So again your OH is replaced by your bromine over here. Now if you look at this reaction, now look at this carbon to which your OH group is attached. Now this carbon to which your OH group is attached is a tertiary carbon if you look. Why? Because this carbon is further connected by other 3 carbon atoms. 1, 2, 3. So this is a tertiary carbon. So when this tertiary carbon is there, so there will be a formation of a carbocation, and that carbocation will be a stable carbocation. Why? Because I told you that if we talk about the stability of the carbocation, then your tertiary carbocation is most stable, then comes the secondary, and at last comes the primary. Okay. So a tertiary carbocation is stable more. Why? Because it has 3 alkyl groups which are donating the electron density to the carbon which is electron deficient. Okay, so that is why the tertiary carbocation is the most stable carbocation. Now what will happen in this reaction? First, we will do the protonation. So when we will do the protonation of your OH group, so this OH groups become OH2 and there will be a positive sign on this oxygen. Okay, then what will happen? The carbocation formation will take place. Now at this carbon there will be a carbocation formation. So here SN1 mechanism is favored because this is a tertiary alcohol and it will form a stable 3-degree carbocation. So this process will move forward by SN1 pathway. Okay, so when there is SN1 pathway, it always proceeds in 2 steps. So first step is the protonation of the OH group. Okay, that is the first step. The second step will be the slow step, that is the formation of carbocation. When we talk about the slow step, then because this step is a slow step, so that is your RDS. It will be a rate determining step. Okay, so second step where there will be carbocation formation, it will be RDS. So now this carbocation will be formed at this carbon. Now your bromine which acts as a nucleophile and this carbon which is electron deficient, so this carbon will attack. The bromine will attack on this carbon and this you will form a bromine group will get attached to this carbon. Okay. So here rearrangement is also possible, but since in this case we do not require any rearrangement. Okay. Now when the mechanism takes place through SN1 mechanism, then the attack can be from both sides, from front side also and from back side also, because this carbocation is a stable carbocation. Okay, so the Br can attack from any side, from front side also and from back side also. So your OH group will be replaced by a bromine group. So this is a nucleophilic substitution. Nucleophilic because a nucleophile is attacking and OH is being substituted by your bromine group. So this is what is happening in this reaction. So this is 2-bromo 2-methylbutane. What will be your longest carbon chain? This is my longest carbon chain. And I'll do the numbering from 1, 2, 3, 4 from this side. So at second carbon, your bromo group is attached and your methyl group is attached. So 2-bromo 2-methylbutane. Okay, so this was the reaction with HBr. So whenever your alcohol will react with HBr, that is hydrogen bromide. So in this case, there will be cleavage of carbon-oxygen bond. Look here, this carbon and this oxygen bond is cleaved now. And the carbon and halide bond is formed. So there is cleavage of carbon-oxygen bond and your alcohol behaves as an electrophile. So to make your alcohol as an electrophile, first you have to protonate your alcohol. So first step will be protonation of your alcohol. And when we talk about a 3-degree alcohol, then this will take place in 2 steps. Okay, the second step will be the formation of carbocation and which will be a rate determining step. Okay. Now, we will see with SOCl2 that how these two compounds react with SOCl2. Now let's see the reaction, how it happens. First comes the butane 1-ol. Now butane 1-ol again is a primary alcohol. So when your reaction will take place with butane 1-ol and thionyl chloride, which is SOCl2, it will produce 1-chlorobutane. So that means you can see here that chlorine group is getting attached. Okay. So what will happen? This reaction will also occur via nucleophilic pathway. So there will be a nucleophilic pathway for this reaction. Now what happens in this reaction? Two byproducts are formed, and both these byproducts in this reaction are gaseous, so they are easy to separate. Okay, we will see in the reaction. Now look at the reaction. It is an alcohol which is butane 1-ol, and this is a SOCl2, that is thionyl chloride. So what will happen first? This oxygen of your OH group, it has electron density to donate. Okay, so first there will be activation of this alcohol. How you will activate this alcohol? That the oxygen which has the electron density, it will attack on your SOCl2. Okay, so what will happen? Your oxygen will attack on your SOCl2, and you will see that to this oxygen, this one hydrogen and one this sulfur and OCl2, that is this groups get attached to this oxygen. So now this oxygen will have a positive charge. Okay, so here is this oxygen. To this one hydrogen is bonded and one sulfur, and to this sulfur your two chlorine and one oxygen is bonded. Okay. Now what will happen in second step? In the second step, what will happen now? One of the chlorine will be removed from here. Okay, so chlorine from SOCl2 will leave, and now this chlorine will act as your nucleophile. Okay, so now when one chlorine is removed, this chlorine will come and it will attack at this carbon. So now the chlorine is acting as a nucleophile. So when this chlorine will attack on this carbon, whole of this group will be left, that is your oxygen to which this SOCl was attached. Okay, so this group will leave, and to this carbon your chlorine will be attached. Okay, so this is how this reaction takes place. Okay, again you can see there is a cleavage of your carbon and oxygen bond, and carbon and chlorine bond is formed, that is carbon and halide bond is formed. Now if you look here, the byproducts are SOCl2 and HCl. Okay, so both SOCl, SO2 and HCl are being released, and these gaseous byproducts, they escape. Okay, so this drives the reaction in the forward direction. So because both of these escape, so the product which you get, 1-chlorobutane, is a pure product. Okay, so it is easy purification. Why? Because this gases escape. That is why this method is preferred more. Okay, so this is how the reaction takes place, and this is through SN2 pathway, because here again this is a tertiary, this is a primary alcohol. Because it is a primary alcohol, so it will go by SN2 pathway. Now we will see for the second one, that is 2-methylbutane 2-ol. Now if I talk about 2-methylbutane 2-ol with SOCl2, now you know that this is a tertiary alcohol. Okay, so when your 2-methylbutane will react with thionyl chloride, it will produce 2-chloro-2-methylbutane. That is your chloro group will get attached. So hydroxyl group, that is your OH group, it is being replaced by a chlorine atom, that is Cl. So this reaction will also take place by nucleophilic substitution pathway, that one chlorine will leave, and now that chlorine will act as a nucleophile and it will attack on that carbon. Okay, so in this the byproducts will be formed, as I told in earlier reaction, that SO2 and HCl, these are formed as the byproduct. Since these gases are easier to escape, so they will escape and you will get your pure product. Okay, now if you look at this reaction, This is 2-methyl-butane 2-ol. To this carbon, your OH group is attached, and this carbon is a tertiary carbon. When it reacts with thionyl chloride, that is SOCl2, so in this carbon, you will see a carbocation will be formed, because this is a tertiary carbon. And a carbocation, tertiary carbocation, is much more stable. Okay, so this process will also take place in 2 steps. Okay, and then a stable carbocation will be formed, and chlorine can attack from any of the sides. Why? Because this is a stable carbocation. So with which pathway it will follow? It will follow SN1 pathway. So that means chlorine can attack from front side also and from back side also. So then what will happen? A chlorine group will attack, and this group will attach to this carbon. That is 2-chloro-2-methylbutane. I'll do the numbering 1, 2, 3, 4. To your second carbon, your chloro group is attached, and to your second carbon, the methyl is attached. And since the longest chain has 4 carbon atoms, so the root word will be butane. Okay, so 2-chloro-2-methylbutane. You should know how to write the IUPAC naming of these compounds. Okay, so is it clear now that how your hydrogen bromide reacts with the primary alcohol? When it reacts with the primary alcohol, it follows SN2 pathway, because there it takes place in 1 step. And when I talk about tertiary alcohol, in this there is a carbocation which is a stable carbocation. Okay, so that is why it will take place by SN1 pathway, and your carbon and hydrogen bond will be cleaved, and your carbon and halide bond will be formed. Now let's discuss the next question. You have to predict the major product of acid catalyzed dehydration. So here dehydration reaction is taking place. Okay. So first is 1-methyl cyclohexanol, and second one is butane 1-ol. So you have to write the major product of acid catalyzed dehydration. So I'll give you 30 seconds to solve, and then we will discuss. Okay, now let's see the solution of this question. So acid catalyzed dehydration, what happens in this reaction? So what dehydration means? Removal of water. So that means we will remove water from this reaction, and when water is removed, you will get an alkene. So acid catalyzed means it is taking place in the presence of an acid which act as a catalyst, and dehydration means a removal of water. So your alcohol will produce an alkene in this reaction whenever there is dehydration. So removal of H2O from alcohol will take place. Now what will happen in this reaction? So whenever you make an alkene, so I prefer that whenever you write, you give the answer for this question, you have to write the reaction mechanism. Why you have to write the reaction mechanism? Because 2 alkenes will be formed in this case, and when 2 alkenes will be formed in this case, you have to see that which alkene is the major one. Okay, so more stable alkene will be your major product. So that is why you have to follow it according to the Sedgwick rule. So it's better to first write the reaction mechanism and see that which alkene is the more substituted or more stable alkene, and that will be your major product. Now when I talk about 1-methyl cyclohexanol, so that means it is a cyclic compound, because cyclo word is used over here. Okay. Now if you look at the reaction over here, then this is 1-methyl cyclohexanol. Okay, to this first position, to this one carbon, your hydroxyl group is attached and your methyl group is attached. So what will happen? First step, you have to protonate this alcohol. This OH group. You have to protonate this OH group because water needs to leave. Okay, so first we will protonate this OH group, so it will become OH2. Okay, so this oxygen will now have a positive charge. Now when this oxygen will leave over here, you will see there will be a formation of a carbocation. At this carbon there will be a positive charge, and this CH3 group will be attached to this carbon. So this carbon will have a positive charge. So this reaction will also take place in steps. And your step 2 is the slowest step, which is your rate determining step. That is the formation of the carbocation. Okay. So your OH2 group will leave, and this carbon, at this carbon there will be a positive charge. Now what will happen? Now if this carbon has a positive charge, then you can form alkene from two ways. How two ways? In first ways, one hydrogen can be removed from here. Look at this cursor on the screen. So here you have a carbon, one hydrogen can be removed from this carbon. If you remove one hydrogen from this carbon, then you will form this one. This will be formed, 1-methyl cyclohexene. And if you will remove if you'll remove the hydrogen from this carbon, from this CH3 group, then this will be formed. Okay, so as I told you, two alkenes are formed in this product. Because if this is a carbocation over here, there are two ways by which you can form an alkene. One, if you remove the hydrogen from this carbon, then this alkene will be formed. And if you remove the hydrogen from this methyl group, then this alkene will be formed. Now you have to choose which one will be your major product and which one will be your minor product. So how you will choose? Calculate the number of alpha hydrogens of this alkene. So if this is an alkene over here, then 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 7 alpha hydrogens are there. And look at this alkene. How many are there? 1, 2, 3, 4, 5, 6. 2 of here, 2 from here, and 2 from here. So 6 alpha. So here this is 7 alpha over here. So that is why this alkene is more stable alkene. Okay, that is why your 1-methyl cyclohexene is a major product and methylene cyclohexane is a minor product, because this alkene is more stable alkene and this alkene is a less stable alkene. That is why I ask you to write the mechanism and then see the most stable alkene. Okay, now let us see the second solution with butane 1-ol. Now when I talk about butane 1-ol, it is a simple carbon chain. So acid catalyzed dehydration, it will produce mixture of alkenes. So here also two alkenes are being produced. Okay, so first but2-ene is formed as the major product according to Syllabus rule. So in the two alkenes, check the number of alpha hydrogen and which one will be the more stable alkene, that will be your major product. And but1-ene is formed as the minor product. Now if you look at this butane 1-ol, first you will do the dehydration. First you will remove the water, that you will protonate this one. So when you will protonate this OH group, it will become OH2 plus. This oxygen will have a positive charge. Okay, now here the carbocation over here is not a stable carbocation because it is a primary alcohol. Okay, so when this OH2 group will be leave, so you will see that you can form alkene in two ways. Okay, what two ways? That one hydrogen over here can be removed. So if the hydrogen from here is removed, you will form but2-ene. Okay, and another one you will form but1-ene. Now because if you see this but1-ene, then if you see if the carbocation is formed from this carbon. Now this carbon is a primary carbon. So this carbon is not a stable one because it is a primary carbon. So 1,2 hydride shift can take place over here and the carbocation can shift to this carbon. Because see, this is a secondary carbon. Why secondary? Because this carbon is further connected to other two carbon atoms. So this is a secondary carbon. So the carbocation will be more stable in this case. So in this case, when but2-ene will be formed, one hydrogen from this carbon, it can go and but2-ene will be formed. And when the hydrogen from this carbon is left, it will form but1-ene. So now if you see, this will be your major product. Okay, and this will be your minor product. Okay, so this is the more stable alkene compared to this alkene. So you have to form the more stable alkene according to Sedzif rule. Now I have to write the ortho and para nitrophenols are more acidic than phenols. You have to draw the resonance structures of the corresponding phenoxide ions. Okay, so it is told that ortho and para nitrophenols are more acidic. Why more acidic? So you have to support your answers through the resonating structures. Now we know that phenols are more acidic. Why? Because they easily donate its H plus ions. Okay, and since this easily donate H plus ions, they are more acidic. Now the negative charge on the phenoxide ion is delocalized in the ring. That is the negative charge which is on the oxygen. It is not localized. That negative charge is taking part in the resonance. So that negative charge is delocalized in your benzene ring. So that delocalization, it stabilizes your phenoxide ion. That is why your phenoxide ion are more stable than your alkoxide ions. Okay, so this thing makes your phenol more acidic. And when I talk about electron withdrawing group like nitro group, it is an electron withdrawing group. So if electron withdrawing group is attached to the ring, it will withdraw more electron density. So if it will withdraw more electron density, the oxygen and hydrogen bond will become more polar. Why? Because the electron density in oxygen is decreasing now. Okay, so the oxygen and hydrogen bond will become more polar, and hydrogen can leave easily. So nitrophenols, that is why when your NO2 group is attached, it will make your alkene more acidic. It will make your phenol more acidic because of the electron withdrawing NO2 group. And NO2 group further stabilizes the phenoxide ion through the resonance delocalization. And as electron density is more renowned in ortho and para position, so your stabilization effect is stronger in ortho and para positions. Now if I'll see the resonance structures of this compound, then look at the resonance structure of para-nitrophenoxide ion. Okay, now look over here what will happen in this structure. Now here your NO2 group is attached at the ortho position. Okay, so if this NO2 group is attached at the ortho position, this O negative, which has electron density to donate, this negative sign will come here. Okay, so this a carbon double bond oxygen is formed. So this double bond will move from here and it will shift here as a negative sign. Okay, so now this resonance will take place. So this is how you will see that this negative sign now comes here, and there will be a double bond with this carbon and nitrogen, and this goes at this side, which forms a negative sign over here. So similarly, there will be movement of your negative charge as well as these pi electrons, and with these resonating structures you can see that how the resonance is developed. Okay, so because this NO2 group is attached at the your ortho position, earlier also this oxygen was donating its electron density to this ring, but now if more electron withdrawing group is attached to this ring, so it will withdraw more electron density. So that is why this will make the phenol more acidic. Similarly, if I talk about the resonance structures of para 1, then for para 1 you can see here your NO2 group is attached at the para position. So similarly you can see the resonating structures, and if you see these negative signs, it are on the ortho, para and again ortho. See here it is as ortho, then it is at para, and again it comes at the ortho. So electron density in ortho and para positions are more. That is why these effect is renowned more on ortho and para positions. Okay, so this is the resonating structures of para nitrophenoxide ion. Okay, now we will look at the next question. You have to write the equations which is involved in the following reactions, that is Reimer-Tiemanns and Kolbe's reaction. So I'll give you some time, you solve it, and then we will discuss. Okay, first we will discuss about Reimer-Tiemens reaction. When we discuss about Reimer-Tiemens reaction, then in this your CCl2 is formed, that is dichlorocarbene. Okay, so phenol, it is treated with chloroform, that is CHCl3, in the aqueous medium, which is your base NaOH, and it forms a substituted phenoxide ion. And then when you do the acid hydrolysis of that phenoxide ion, you will see a aldehyde group is formed, that is cellulose aldehyde group is formed in this reaction. Now this reaction, as I told, it involves the formation of a carbene intermediate. Okay, so a carbene intermediate which contains 6 electrons is formed in this reaction. So if you look at this process, first you have a phenol. When your chloroform and aqueous NaOH, which is a base, reacts with your phenol, then you see a sodium phenoxide ion is formed, that is O- and Na+. Okay, and to this ortho position, the CHCl2 group will be attached. So one thing which you need to remember is that the nucleophilic attack will take place from this carbon and not from this oxygen. Okay, so nucleophilic attack will take place from this carbon. So to this carbon, your CHCl2 group will be attached. And when it is treated with NaOH, so you will see that this CHO group comes over here. That is, this aldehyde group is attached over here. And when further acid hydrolysis take place, you will see that here you will get cellulose aldehyde over here. Okay, so this is your final product in the case of Reimer-Tiemens reaction. Now next, when we talk about Kolbe's reaction, then what happens in Kolbe's reaction? In this reaction, first when you treat your phenol with aqueous and with NaOH, that is sodium hydroxide, it forms a phenoxide ions. Now the condition is under high pressure and temperature. So here your CO2, it acts as a weak electrophile because your phenoxide ion, that is sodium phenoxide, has very higher plus M effect. The ring is already very activated. So the reaction can take place even with a weak electrophile. So here a CO2 acts as a weak electrophile and it reacts with sodium phenoxide to give an intermediate. And the reaction, it occurs predominantly at the ortho position. And when further you will do the acid hydrolysis, then your cellulose 2-hydroxybenzoic acid will be formed in this reaction. So if you look at this reaction, then this is a phenol. When it is reacted with a base, it forms a sodium phenoxide ion. Now this ring is already very activated, so it reacts with a weak electrophile. Now here also nucleophilic attacks take place from this carbon. So to this carbon, your COO group gets attached. That is 2-hydroxybenzoic acid or salicylic acid. Okay. So this is how your Kolbe's reaction takes place in 3 steps. Now let us summarize whatever we studied. We studied about the methanol, which is the simplest alcohol, and production is done using carbon monoxide and H2, which produces your CH3OH. And here zinc oxide and Cr2O3 acts as your catalyst. Now the properties are that this is a colorless liquid and the boiling point is 337 Kelvin. 337 degrees Celsius, and this is a very highly poisonous. Okay, even the small quantity of methanol is very poisonous. Now if we talk about ethanol, which is C2H5OH, then production is done using the fermentation of sugar and hydration of ethene. And if I talk about properties, then it is a colorless liquid and the boiling point is 351 degrees Celsius. Okay, thank you students for attending this lecture. I hope today's concept is clear.